So let's move to the discussion. There are many interesting research results and research topic from the very bottom level to very high level or very simple grounded model. But as Lorenzo first mentioned that even very simple task for robots, it is very difficult. So I want to start the discussion from the physical interaction with the environmental robots. So based on that, I want to ask the Lorenzo, what is the problem or what is the difficulty for grasping, or not only just grasping, the physically interact with unknown environment? How do you think, Lorenzo?
Yeah, thank you. So, well, it's a big list, but I think so. One thing you mentioned already in the introduction, which is the uncertainty. The fact is that, as you just said, these are simpler problem, but they are apparently simple. Because if you approach them from an engineeristic point of view, in which you have a certain number of variables that you want to control, is actually, if you think about the number of variables that you would like to control when you approach the grasping of an object in a completely unstructured environment, it's a huge number of variables. So clearly you cannot approach it from a, let's say, I will call it a standard engineeristic point of view, because the number of variables is too high. It's actually a complex problem if you think about it. And this includes understanding where the objects are and understanding their properties, how to pick them, how much force you need to apply in order to keep them stable. So you basically, of course, it's difficult to scale from the structure to the unstructured, because in the structure you can simplify the problems, and that's why in robotics, in industrial environments, the number of variables that you have to control, it's reduced artificially by simplifying the environment, right? So, and then you can have previous information about the objects, because you know exactly which objects are you dealing with, their shape, their stiffness properties, their location. You can simplify as much as possible, and then you come up to just a very limited number of variables that you have to consider. Even in those cases, you may have uncertainty, but again, by structuring the scenario, you can reduce also the uncertainty, right? If you cannot do that, if you are in a arbitrary environment, then the problem becomes very complex.
Okay, thank you very much. Very interesting comments. So from Roland's comment, I think that can be extended to the two directions. One is sensing, and the other is the generalization of that information. So I want first discuss about the generalization. So I want to ask Professor Nagai. So you did many of object for try to grasp and create some information for generalizing such information. So do you have any comments for this kind of problem?
Well, I think the kind of generalization regarding objects is not so difficult. I mean, recently we can make the robot learn how to, you know, recognize the object. I mean, the general object recognition is not so difficult problem nowadays. So making robot learn how to recognize objects is not so difficult, but handling or manipulation is a little bit difficult, as Roland said. And so, which means that we have to make the robot learns not only visual recognition, but also how to use it, the property of the object, and so on. So it's a totally multimodal problem, and learning that kind of, you know, generalization using multimodal information is big problem, I think. So we have to pursue that direction.
I see, thank you. But I think you said that a kind of generalization is not so difficult problem, but grasping or touching or operating, handling, such kind of motion with the behavior with motion and generalization of the properties should not be discussed separately, I think.
Right, right. So it is important. In other words, we have to consider that kind of, Mauch model or object property and action and so on. At the same time, it's very important to make the robot learn, actually make the robot actually can generalize the object and so on. So yeah, I mean, what I said is to general object recognition is not very hard nowadays. I mean, thanks to the big data. But for robotics, it is really hard to do it, and meaning that the robot need to run locally. I mean, trial and error. So that is very important to think about everything at the same time.
Okay, thank you very much.
Sorry, can I make a very quick comment about grasping? Because grasping, I think we have to consider that is never just grasping. It's always grasping to do something, right? So the thing is, then in a lot of robotics research, grasping is for pick and place. And maybe pick and place, even just very simple pick and place, picking something and throw it into a box. And that is a simple task. So grasping for that task, maybe there is a lot of research now, relatively easy, but it's not grasping. It's a simple task. It's grasping for a simple task. Grasping is then required if you want to use the object for something else. It becomes something much more complex. So.
Yeah, that's true. So the behavior is not separated each other. Everything is seamless connection from the behavior interaction to the symbol grounding. So we want to go to that direction of discussion, but before going that, I want to ask Dimitri, as I said, I like you hunting or be hunted, but another interesting phrase you said in introduction was, when stop sensing and start acting. That point is also another important factor for interacting with the environment or sensing environment. But I want to ask more about clearly what do you mean, or what is the principle or important factor for when stop sensing and start acting?
So that is kind of a exaggerated question, because in theory, interaction with the environment should be continuous and there should be a loop. But when you consider that you have continuously uncertainty on the environment, there is a trade-off between acting to achieve your goal, or acting to improve your certainty on the environment. This is a continuous trade-off, and obviously increasing your certainty on the environment requires to waste time and waste also computational resources. So this is a complex problem. We cannot imagine to have a robot that has enough computational power to process the real state of the world. The real state of the world strongly depends on what you want to do. So for example, if you want to cross the road, the state of the car that is coming for you is interesting only the speed, the velocity, and maybe the light, if the car has the lights on, something like that. But if you want to repair a car, the state of the car is a much more complex content and information to process. So a system has to decide what information needs to extract and to process. And this is a complex problem that we have to solve, because we cannot think that a system will really solve and compute all the variables at the same time. So there is a kind of mirroring between the process of acquiring information selectively, so extracting information you need, and actually deciding which information you want to process. So I think these are interesting problems that can be formalized in a similar way, because you can formalize using information theories, the sense of how much I gain of getting more information or processing more information. But they are complex problems. The fact that you can, in theory, formalize them doesn't mean you can really apply in a general on a robot. So the problem of deciding to stop to process information, to get information, I think is a very big problem. It's what is called a frame problem in some way. Deciding that you have enough information without checking all the other information. It is a very complex problem, I think.
All right, thank you very much. Yeah, that is true. So many problems simultaneously exist for robot controls. So in that case, that we need to understand the situation in something like context based. So yeah, right.
Yes, so the context and the action you want to do in some way define what information you are taking, but the information you take define the context. So maybe the process is not that trivial.
So that is Alessandra's topics. So context-based communication. That is another important factor for social robots. So what is the difficulty of the context-based communication rather than the physical interaction or language? Language might be that's such kind of one. So please, Alessandra.
Even if we stay before language, so even if we think of children before they learn to actually properly use fully language, we see how they are very good at establishing an effective mutual understanding, both with peers, but also with younger children sometimes, and often with older and adults. So. And this is based on a lot of abilities that we start up with. So we have them as innate in some case, or we develop very early when we are young, that allow us to detect in the other what is meaningful for establishing mutual understanding. So we start from being very infants and realizing and detecting biological motion, or recognizing when someone is looking straight to us. So this means that soon we start building up on basic abilities to establish a sort of mutual understanding, or a shared understanding of the environment and of each other. This is something that I feel is still very much missing in current robotics. So to come back to the example of grasping that also Lorenzo pointed out before, beyond this idea of having a goal, so for which, you know, this changes the way you grasp, but imagine you're not doing it alone, you're doing it with someone else. So if I know that I'm grasping something to pass to someone else, or to allow this someone else to understand my behavior, I naturally change my behavior to signal, because I predict, I understand what the other person will see. I predict how to maximize the mutual understanding, and this improves our collaboration. So in this respect, there is an additional dimension to context, if you want, that is given by understanding, realizing, and keeping in mind that the other agents are not sharing our perception of the world. They are not for free. And so we continuously not only have a representation of what, or a sensing of what's happening, but we are also trying to predict what the other person is perceiving. And we are trying to signal or to behave in a way that is more understandable for them. And we try continuously to read what their actions, or what's hidden behind the action. So basic things, very simple, as in the examples that were pointed out. I can infer immediately how heavy is an object you are manipulating just by watching you manipulating it. Even without you wanting to show it to me, it's something that I read already. So it's a continuous flow of mutual information by which we continuously make sense of the other and of his own goals, and allows us to anticipate and predict. So I think that one of the main missing points, or the challenges, is really to enable this understanding and this prediction about the other. Maybe also by leveraging the very same mechanisms that allow us to do so when we are interacting with other humans.
Okay, thank you very much. Yeah, that is very important. Prediction and talk with futures, or of course, the talk with past is also important. So, in that point of view, I think that I want to ask the Professor Oseki, what is the language communication is special point comparing with other communication or other communication way in cognitive science point of view?
Hey, oh, that's a good and a hard question. Yeah, and there is still debate between like a rationalist point of view and also empiricist point of view, like where like some people argue that language is learned like based on like just like nothing, right? Yeah, and by using some data from text or some like uncertain environment, and without assuming like any innate knowledge. And but some other people like still argue that like nativist and rationalist traditions argue that like language is kind of special and like genetically programmed, like humans can speak languages like without like much experiments based on the environments or some text data. And I think like going back to the meaning representation, like first of all, like I want to assume that meaning of words are like ultimately represented in the brain, so they are maybe represented in the distributed fashion. And as Alessandra pointed out, like human kids are like learning like from very noisy and uncertain environments. Yeah, yeah. And I think like a recent like language, for example, NLP researchers have assumed that like meanings of words can be learned based on the huge data of like Wikipedia, for example, by using just linguistic context. But human babies or human kids are learning from like a more like a multimodal like information from the actual context, right? Like Taniguchi-san has been working on this topics. I will leave that topic for Taniguchi-san, but so in that case, we should like contextualize a language which is usually assumed to be special within the like robotics context and try to integrate like multimodal information, not only like linguistic information, which like NLP researchers have been doing recently. Yeah.
Okay, thank you very much. I want to discuss much more, but time is limited. So I want to ask Taniguchi, Professor Taniguchi, your work is from the physical interaction to language or connect with with a seamless connection. What is the difficulty for that? Very simple. Sorry, very vague question, but that is very important for each segment might be possible to develop, but connect everything.
Yeah, that's right.
What kind of difficulty exists for that?
Yeah, there is a full of difficulties. But actually, in the AI field, recently, a system 1, 2 is gathering attention. So the how to say integration of the symbolic system and the physical sensor motor system is a long-standing problem. And but actually, actually we want to work on such kind of problem. And Ozeki-san said, the NLP people are looking at just the text data and the big data, you know. So the deep learning method can deal with many kind of tasks in natural language, but it's just text, you know. The children, no children learn language just from text. We have the multimodal experience, and yeah, so that we have said my children they learn many words and phrases and meanings from daily interaction, actually. So how say So, currently, when we look at the robot, the physical, to deal with the physical uncertainty itself is still a very hard problem. Okay, so from the viewpoint of the NLP, if we want the system to NLP system to truth the whole range of the vocabulary, the whole range of text is full of uncertainty. And actually, currently, the robot cannot deal with the every type, every object and every events in our environment. So actually, in my slide and Nagai Sensei's slide, so that the robot deal with many objects, but only objects the robot can grasp. The robot could grasp. The robot could not deal with the table itself, I think. So we need to connect the two areas to the NLP level and the robot level. Actually we need to make a robot we need to make a robot deal with much more event and object. Yeah. And then in addition to that, the huge challenge is to deal with abstract concept. So the robot can understand the meaning of the bottle or scissors, something like that. But how can we make the robot understand love or democracy or even the more simple abstract concept? So yeah, there are many kinds of difficulties, but yeah, I have to stop, I think.
Okay. Thank you very much. Yeah. So from the interaction with the environment to the symbol grounding and the language, so many problems, not only just elements, but the connections. Okay, now I think that's observers and in YouTube attendees have, I think that there are many questions. So now we want to ask the people to ask questions. If you have questions, can you turn on mic and ask directly? So you talk. So from the YouTube one, there one question. So Alvaro make a question.
Okay, can you hear me? Okay, so there is one, well, I will not say it's a question, but it's more, I almost proposal of a topic of discussion. This is actually directed for Professor Nagai. I will read the question, it's very short here, but it's a little bit out of context now, so I will try to interpret a bit and contextualize this comment. Basically, the comment is by Gyanendra Tripathi, which says, Professor Nagai, can you explain a little about self and other discrimination? So this question was requested during the introduction of Professor Nagai, in which was showing these autonomous robots moving around and picking up objects. So I guess this question is trying to open some topic of conversation about the robot being able to recognize which part of the environment itself and which part is other selves. So I think also during this introductory talk, there was this discussion about consciousness, what is consciousness and how we should implement this in robots. So I think this topic is slightly related, because at the end, one of the initial parts of implementing a level of consciousness is to be able to recognize or to create this difference between myself and the rest of the world. So can you, Professor Nagai, please explain a bit, or what do you think about this topic?
All right. The self and other discrimination, there are a lot of research on how we, I mean, in the context of robotics, there are some research on how robot can discriminate self or another and how to recognize its own body and others or external world. So what I said is just in my current model doesn't have that kind of functionality. So what I want to say, is just I need to implement that kind of functionality. But as you said that for thinking about the consciousness, maybe that kind of self-other discrimination is very, very important, because actually current my robot cannot understand if I tell the robots the name of the robot, or for instance, I said to the robot that my name is Takayuki, but the robot cannot understand, because actually my existence is exactly the same with the object. So it's not human, but just an object. And if I tell him the name of the robot, but he doesn't understand at all. So in that sense, self-other discrimination is very important in primitive, but also it is a very, very important core for consciousness. I mean, the self-awareness. So I think that is a future direction in order to pursue. But right now, I don't have any idea how robot can have consciousness. So I'm just proposing we have to think about it. But right now, I don't have any idea how to do it. But the self-other discrimination is, or I'd like to say that mirror neuron system is required for that.
Okay, thank you very much, Alvaro, and thank you very much, Professor Nagai. Do you have any other questions from the observers? Okay. All right. So